Hello everyone, this is Amir from Audio Science Review. I'm back with another review, this time an amplifier from Topping called the B200. It's a single channel monoblock. As you can tell, it's quite heavy for its size. It's a pretty chunky, very well made box. I mean, you could literally drive over it 10 times, it'll be fine. It's a single channel, as I mentioned. It's got a power button that also acts as an input selector. There are 3 inputs, even though on power amplifiers we usually don't need multiple inputs, but I think they had this enclosure feature in their other products and they just ported it over. The back of it being quite chunky and large gives you plenty of room to hook up even the beefiest cables over here. There are 2 gain settings, low and high, and I'll show you that effect later on. It's got an external power supply, I'll show you that in a minute, and then the 3 inputs on this thing. So put this away. The thing that some people like and some people hate is the fact that the power supply is not built into the amplifier, but it's a separate 60 volt 4 amp power supply, quite beefy switching power supply. The advantage is that this is the part that usually goes bad in amplifiers. I shouldn't say usually. Half the time it's the power supply that dies. And here you just have a replaceable power supply that you likely can even get from third parties if Topping doesn't offer it. The downside is that, you got this thing and it's not inside the thing. It also doesn't contribute to heat in the amplifier, allowing it to be that compact for the amount of power that it produces. So let's see how it performs. Let me switch to my browser and then we'll go through the review. I've already covered all the features. The one thing I didn't cover is the trigger input. For those of you who don't know what trigger is, you can hook up this basically a headphone cable to your source, and when you turn on your source, it'll raise that 12 volt signal, which then in turn causes the amplifier to turn on. So quite a useful feature to have. If you're not familiar with my amplifier measurements, I have a whole YouTube on that called Understanding Amplifier Measurements, but I will also explain enough in the process of going over this review. The dashboard, the first test I run is a 1 kHz signal. You can see that here, excuse me, and I drive a 4 ohm load. And I measure what voltage, input voltage you need to drive that to 5 watts. And in this case, in low gain, you need a lot, 1.18 volts, almost 1.2 volts to drive it to 5 watts. The gain is little less than 12 dB. Topping has a companion preamp that's able to drive this to full power, but not all DACs can do that here. The performance is just incredible. We see the distortion that doesn't rise above minus 140 dB. Threshold of hearing is around minus 115 over here. So you've got, 25-30 dB of headroom over here. And this is utterly transparent. There's no noise and distortion that's going to get in the way. So naturally, when we plug it in here, we see that it lands on top, although Topping B100 and LA90 are also up there. They're all just a fraction of a dB difference. So consider all these to be the same as far as that's concerned. When we go to high gain, now we only need a quarter of the input voltage, 0.3 volts, 0.4 volts to drive the same 5 watts. And the gain jumps up to 22 dB now. And performance drops 5 dB, but you can still see that the distortion products are at minus 130 dB and still well below threshold of hearing. With high gain, you can drive it with just about any source. Any modern DAC or preamp should have no trouble driving this amp to maximum power. This SINAD number that we talk about is sum of noise and distortion. In many state-of-the-art products, distortion is way, way lower than noise. So we're really measuring noise. And you can see that over here. If I just measure noise in low gain, our noise figure is 123 dB. So very close to the 120 dB that I was showing before. And to get full power, though, you need 6.6 volts. Typical DAC only outputs 4 volts, so that's why I say you may need a preamp if you want to run this directly from those products without using Topping preamp. Or an audio interface. Professional audio interfaces have no trouble producing this much voltage. It's just stunning. My standard for 5 watts, what kind of signal noise ratio I like to see is 96 dB. In other words, at 5 watts, I like to see it clear the CD dynamic range. And this thing goes way past 96 and is at 123 dB. So it's got 21 bits of dynamic range at just 5 watts. And if you let it go to max power, it goes even crazier. Now we have 23 bits. There's no music in the world that's this good, that has this kind of dynamic range, or even this one. And it's just stunning performance. Even high gain is great. We have 19.3 bits, or 116 dB. So it passes threshold of hearing. It's fully transparent even in high gain. And then when you go max power, you again hit with 130. And this is a conventional Class AB design. It is not a Class D, which many of these small amps are. And one benefit of that, it has the output impedance doesn't change with frequency. And therefore, if you change the load from 4 ohm to 8 ohm, as I've done here, nothing changes the two graphs as far as frequency response. And you can hook up reactive loads to it, like a speaker or whatever. The amplifier frequency response does not change, which is very nice from that point of view. And of course, we go all the way down from 10 hertz to 100 kilohertz plus, so no issues there. We measure intermodulation using this 32-tone signal we call multi-tone, and you can see threshold of hearing is well past over here, and we have 21 to 20 bits of distortion-free range. Even high frequencies, this is a test I run, 19 plus 20 kilohertz, that stereo file runs. So if you want to compare my measurements to theirs, it's a good test to use. And still, we have 19 bits of distortion-free range. This is quite good. Many amps sync down to 14, 13, or even 10 bits. I ran a soup to see how much power we get, and both at low gain and high gain. And low gain, we can see that it beats our reference, which is the benchmark HP2, which is an extremely good amplifier itself, but this amp has no trouble exceeding its noise performance. At high gain, it sort of wiggles a little bit, and there's some kind of notching happening here, which may be some kind of voltage switching, I don't know, inside the amplifier. It's harmless, though. It's at very low level, but something's happening here. And then from here on, we actually limited to the analyzer performance, so it goes way up there. And so as far as noise and distortion across the full power bandwidth is extremely good. That was at 4 ohm, and this is at 8 ohms, and we still get a lot of power, 153 watts at 8 ohms. A lot of times the amplifiers get half as much power at 8 ohm that they do at 4 ohm, and this thing still produces really good amount of power. If I allow 1% distortion, we get about 170 watts maximum power and burst. There's no headroom because the switching power supply is likely regulated, so it doesn't allow it to go higher than this amount of power, period. I noticed that if I keep running this test, this number started to keep going down and down to 160s. If I waited a little bit, it would go back up to 170s. So there's some kind of thermal pullback, tiny amount, if you push it past this clipping point of 170 watts. I have a new test, which I call the ASR power test, where I measure the power at 40 hertz, because that's the peak I've noticed in a lot of music as far as bass. And we get the same power that we got at 1 kilohertz. This test is at 1 kilohertz. This one at 40 hertz. And then if you want to know what power you get across the full sweep, you can see this goes 20 kilohertz, goes all the way down to 20 hertz. And the test starts from the right and goes to the left. There's a new spec from Federal Trade Commission that mandates 5 minutes of full power testing. It's a terrible test and terrible regulation. I won't go into it right now, but this is a more sane version of it. For 1 minute, I bang on the amplifier, constantly pushing it into clipping to determine its response at different frequencies in here. And we see that it starts at 177 watts at full 20 kilohertz, and its power reduces down to about 153 watts. So a little bit of reduction, I don't know, it's 10 or 15% when you go down to 20 hertz. And that's typically happens. It's harder to maintain 20 hertz power than it is to maintain 20 kilohertz power. Although there are amplifiers, that Class D amplifiers, that don't like high frequencies, and they reduce power there too. The power testing is done at 1 kilohertz, but a lot of people ask what's the performance at other frequencies. So we run the power sweep, and as I just mentioned, you actually get more power at higher frequencies. Like you can see at 20 kilohertz, the power is higher than if you go down to 1 kilohertz or 20 hertz. But this is what we call a transfer function, which is, what goes in and what comes out. This is exceptionally clean and exceptionally low noise. If you had a Class D amplifier, for example, this would go up and down and wiggle. Many amplifiers are way up here. Tube amp would be way the heck up here. So extremely, extremely clean amplification. I have a monster box behind me that you can sort of see. The German company makes it, called the load box, and it allows me to simulate not just resistive load but also reactive load, which means that the current and the voltage are not in sync, either one leading or one lagging. And I measure the same maximum power as before, but with different kinds of loads, and I measure the voltage. It's kind of hard to see, to understand what this means, so I'll translate into watts, and you can see that, how the wattage changes based on the reactive load. And I was pleased that the amplifier went down to 20 ohm, at least on 3 out of 5 tests it was able to get down 20 ohm, even though it's not specified for 20 ohm. Maximum power is available at 4 ohm, but also a good bit of power is available in 8 ohm. As I mentioned, usually the 8 ohm power would be half as much as this on this thing. Turning it on, I turn the amp on and off, and I monitor what happens. This is exceptionally clean performance. I've only the B200 from Topping I've noticed is this good. Many amplifiers jump above this 1 millivolt threshold I have for potentially audible pop when you turn the amplifier on or off. Some amps make noise on turn on, some on turn off, some on both. Here, we're usually below that. So not only is this amp quiet when you're listening to it, it is absolutely quiet also when you turn it on and off. And it's just this spikes, you just get a one on pulse, one off pulse. Many other amps, they jump up and down before they stabilize. And of course, the noise floor is just stunningly low. Another bit of good news is that when you turn it on, it just produces its best performance as soon as it's turned on. It makes no difference at all, so feel free to turn it off when it's not in use. So where do we land? Of course, performance is superb. But one of the developments that until now, Topping had produced these very, very high performance amplifiers, but the wattage was sort of the low to medium. This is the first high power amplifier that they have produced that I can actually start using with my large Revell Salon 2 speakers. I like to have a few hundred watts of power, so I never run into clipping, and it's nice to see that this amplifier approaches 200 watts. So there's plenty of power available and state of the art. It doesn't get any better than this. There's no amplifier that has this much power and this level of noise and distortion and transparency. It just doesn't exist. Okay, by the way, the amplifier is $600 each, so get 2 of them, cost you $1,200. All right, see you in a future video. Bye-bye.